Hi guys, I'm Ina Kurniawati. Now I'm going to share about magnetic motor starter. What is magnetic motor starter? Magnetic motor starter is an electromagnetically operated set of contacts that start and stop the connected motor load. This is the appearance of magnetic motor starter. Okay. A control circuit with momentary contact device connected to the coil of magnetic motor starter perform this start and stop function. A 3-pole full voltage magnetic motor starter is made up of the following components: a set of stationary contact, a set of movable contact, pressure spring, solenoid coil, shading coil, moving armature, and a stationary electromagnet. It's also important to remember that a magnetic motor starter is a contactor that has the addition of an overload relay assembly that provides running overload protection to the motor. Selection of the thermal overload relay is done using the manufacturer's table included with the magnetic motor starter. In addition, ensure you know the full load current or FLC of the motor and the service factor or SF and the ambient temperature in which the equipment is being operated. Thermal units are based on an ambient temperature of 40 degrees Celsius or around 104 degrees Fahrenheit. Okay, that's a little description about magnetic motor starter. Now we're going to discuss about the type of magnetic motor starter. Okay, typical magnetic motor starters that are commonly available include full voltage, like this one, and then reduced voltage, which is the reverse of the full voltage, and the last one is reversing contactor or reversing starter. Now I will try to explain one by one. Firstly is full voltage. It applies full voltage to the motor, and it means the magnetic motor starter is designed to properly handle the level of inrush current that will develop as the motor is started. And the second one is reduced voltage. In reduced voltage, it's designed to limit the effect of inrush current during motor startup. So, if you want to underline the keyword for full voltage, you have to underline handle the level. Okay, just 3 or 2 words, handle the level. And if reduce, the keyword is limit the effect. Okay, and if you want to have more discussion about reduced voltage, you can see Standard Motor Control Circuit Primer in the June issue of ECNM on page 18. Now the last one is reversing starter. This one. Okay. Reversing starter designed to reverse self-rotation of a 3-phase motor. This is accomplished by interchanging any two-line conductors that supply the motor load. The reversing magnetic motor starter feature a forward and reverse. This is forward and this is reverse. Okay. Forward is symbolized by F and reverse by R. This is F, this is R, and this is forward, this is reverse. Electrical and mechanical interlocks are provided to ensure only the forward or the reverse starter can be engaged at any given time, but not at the same time, because as we can see here, this is connected parallel, so it uses all functions. If there current flow here, so the current will face a branch here and here, F line and R line. So when the current flow here, one of the branch will close and the current will go through the line. If the both of them close, the current will confuse which line will the current choose. So it has to be only one line. Okay, I think enough for the discussion about the type. Now I'm going to give you a simple example of magnetic motor starter. This is the image of 10 EE Kepler-Hammer magnetic motor starter. Okay, from this one, and this is the diagram of the picture. So you can compare that the two is both of them is same, but this is the machine and this is the wiring diagram of this machine. Okay. Now I'm going to explain this diagram. In this diagram, as you can see, this is the symbol of coil, this is the symbol of overload heater, this is overload heater, and this is overload switch or reset button. This reset button. Okay. This configuration seems to be the way most 10EEs were wired. It's not the correct configuration for a 10EE that is run from a rotary phase converter or RPC. For RPC operation, the left terminal, this is left in your point of view, at your point of view, so I will explain it by your point of view. So this is left, the red line is left, and the magenta line is left. Okay, this is left and this is right. I'm sorry, this is left and this is right. So the left terminal will connect to L1 in RPC system, not in L3. And the real phase of RPC will connect to L1 and L2 because L1 and L2 have overload protection. So it carries most the current in typical RPC system. The coil is moved from L3 to L1 because the artificial or wild leg of an RPC may not provide a stable voltage at startup, and starting problems can occur if this diagram applied to RPC system. Okay, this diagram showing the coil circuit startup when the start button is pressed. The startup circuit is complete AC or alternating current input going through L2 and then going to the center of headstock. This is the switch of headstock, and then go to the terminal 3 in the start switch, and the start switch connected to the stop switch, and stop switch turn up to the overload switch or reset button. And the one terminal of the overload switch or reset button connected to the one terminal of the coil, and the other terminal of the coil connected to L3. So all of this red line and magenta line completing the circuit. This reset button used to when the condition of the L1 or L2, they are overcurrent in L1. So the switch will open and the motor will
turn on. So have to press the reset by the operator. Note if there any interruption in any portion of earth line or magenta line, the coil will not energize and the MG is motor or machine, will not start. And this is the diagram of running. So this diagram only shows us when it starts. Okay, when the start button pressed, only at that time. This is running. So when we release the start button. Okay, in this situation, the coil is already energized. The large 4-pole main relay at the top of contactor closed. So the contactor on the right end, this is right at your point of view, going to terminal 3 and directly go down to terminal 1 in the stop switch. By pressing the start and head stop, because in starting diagram we're going through the head stop first and then at the start finally to the stop. That when the coil already energized, the current flow directly to the stop button. So if either the overload switch, this overload switch or reset button, and the stop switch open, the circuit is interrupted and the contactor will open and the MG will shut down like that. So I think enough for my explanation. I know that there are so many mistakes, so I'm sorry about that. As always, correction, clarification, and question are very welcome. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.